Good morning. Nice easy lesson today, 12.1. So we're starting a new unit. It's evaluating limits numerically by substitution. So the other time we did limits, we looked at the graph. So what I want you guys to do quickly is to look at the graphs in the warm-up. We'll do them together. And we will talk about the limit and how to look at it on the calculator. So visually, let's see. All right, we go to y equals. Let me clear it out. All right, we want the limit as x approaches 3 for 2x minus 1. This is a line. So a line is going to be continuous. It's going to be really easy to see the limit. But let's just type it in. 2x minus 1. I'm going to look at the graph. And it's real easy to tell when x is 3, 1, 2, 3. Well, I know that there's definitely a value. So let's look at the table. All right, when x is 3, your y value is 5. So the limit as x approaches 3 is 5. All right, we'll get back to that when we go into the lesson because that's interesting. Over here, the limit now as x approaches infinity, so that says x is getting larger and larger and larger, so you got to scroll out to the right of x squared plus 3. So let's go back. X squared plus 3 is a parabola shifted up 3 units. You guys should know that from the formula. X squared plus 3. Let's take a look at the regular graph. All right, so remember, the limit as x approaches infinity. So as x gets larger, where is y going? If I zoom out a little bit, you'll see that it's just going to continue to rise, okay, forever. So as x gets bigger, your y value gets bigger. So your limit is positive infinity. And if you looked at your table, you would just see the values getting bigger and bigger and bigger and never going down, okay? All right, next one. Now the limit as, we have an n here, as n approaches infinity. So as n is getting bigger, the limit of 1 over n. Now I want you to think about this. If n was 2, you'd have a half. If n was 4, you'd have a quarter. If n was 8, you'd have an eighth. So it's going down. So the idea is, take a look at the graph. 1 divided by x, and just look at it. I'm actually in a zoomed out window from before, so I'm going to zoom back to regular. All right, and as x approaches positive infinity, it looks like the y value is going to 0. So let's just kind of confirm that with the table. All right, so I'm at 0.6 here. All of a sudden, I'm at 0.4. 0.3, 0.2. Yeah, so it's heading down to 0, and that should make a lot of sense to you guys. So it does have a horizontal asymptote at 0. Remember, bottom heavy, right? This is n to the first. There's no n up here. So like that terminology is going to come back in to play again. But I want you to look back at this first warm-up example. And the first warm-up example, said when x was approaching 3, the value was 5. We could get that with direct substitution, right? If x was 3 approaching 3, 2 times 3 minus 1 gives us 5. And that's what we're going to build on today, the idea of direct substitution. So in this first one, right, and try not to use a calculator here. I know it might, be a little rough, but it's not too bad. So we're going to try direct substitution. If you sub in an x value and it gives you a y value, that's going to be your limit. So that's the easiest case scenario. So in letter A, example 1, we have the limit as x approaches -1 of x times x minus 1 squared. So I don't necessarily know what that looks like. It's a cubic if you multiplied everything out, but yeah, no clue. I mean, I do have a clue, but I'm going to make like I don't. So I'm just going to sub in for x. Okay, so we have -1 times -1 minus 1 squared. So that's going to be a -1 times -2 squared. That's 4. 4 times a negative 1 gives you a value of negative 4. Now, I mean, you could go to your calculator. You could go to y equals. You could type in x times x minus 1 squared and check the table. And when x is, oh, I'm all the way up there. When x is negative, oh, I looked at negative 4, silly me. When x is negative 1, your y value is negative 4. So like I said, you can use your calculator, but you know, every once in a while using your brain would actually help here. All right, so in letter B, we have a cubic again. X is approaching negative 2. Let's see if we can get the limit through direct substitution. So a negative 2 cubed minus a negative 2 plus 5. All right, negative 2 cubed is a negative 8. A negative 2 is a positive 2 plus 5. We should get a negative 1. So I'm going to double check. X to the third minus x plus 5. Check my table, and when x is negative 2, I get a negative 1, and life is good. All right, so what I want you guys to do, we'll do them together, or I'll just write them silently. You guys can either pause the video and then do them on your own and check, come back to me, but I am going to just work these out. So direct substitution, sub in, evaluate. So in letter A, I substitute in a 2. Okay, so back to me. First one, real easy. Plug in that 2. You wind up with a 7. No problems there. Letter B, I mean, you sub in a negative 2. You get this negative 6 to the 2/3. I kind of left it like that because it's not a nice number. If it was, say, a multiple choice and there was a decimal, maybe type it in. But negative 6 to the 2/3, make sure you're in parentheses. That's fine. But C and D are interesting because they bring back in some E's, they bring in some LNs, they bring in some trig. So it's not that bad. You still do direct substitution. So like in letter C, where x was 0, e to the 0, sine to the 0. All right, so the first part, e to the 0, anything to the 0 power is 1. Sine of 0, go back to your unit circle. I'm telling you, this is the most useful thing ever. Sine of 0 degrees is here, it's 0. So 1 times 0 gives you 0. Likewise with letter D, we brought in an ln, sine of, and now we have x approaches pi. That's a little weird, but let's just go with it. So pi over 2 we know is 90 degrees. So ln of the sine of 90. Sine of 90 up here is 1, so ln of 1 is 0. If you didn't know ln of 1 was 0, you could type it into your calculator, okay? All right, so moving on. Of course, it's not gonna be all sunshine and rainbows here. We do have places where direct substitution isn't always going to work for you straight out of the gate. So what I want you to do is I want you to look at letter A, and we're talking about as x approaches negative 3. We want to explain why that limit cannot be found by direct substitution. All right, I want you to think about this for a sec. Why would negative 3 not work in letter A? Reason being, if I popped in a -3 in for x in the denominator, a -3 quantity squared would give me 9. 9 minus 9 gives me 0, and that gives me an issue. So I can't substitute in because I'm going to go undefined. So it's not that bad. So what you want to do is just look to factor. Okay, so the first step, if you're looking to find a limit algebraically, is 100% like the other page, sub in the value. If you get a good y value, that's your limit. But in a case like example 2a, you wind up being undefined. So we have to hit up another method. So you're still going to eventually substitute, but what you're going to look to do is look to factor. So I know it's been a little bit. So let's just look to factor the numerator. All right, so we have the limit as x approaches -3. Now the top, remember trinomials, you want to multiply to a +12, add up to a +7. So signs are the same, both positive. Two numbers that multiply to 12 that make a 7 would be x plus 4 times x plus 3. On the bottom, x squared minus 9 is a dots problem. So x minus 3, x plus 3. And these cancel, which now leaves us with a great reduced rational expression. So we have x plus 4 on top over x minus 3. And if you notice now, substituting in a -3 doesn't make a big difference. It's not going to cancel you out and make you go undefined. So now you directly substitute. So you have, I don't know if I'm going to run out of room. Let me double check. You're going to have a -3 plus 4 over -3 minus 3, which is going to give you a +1 up top and a -6 on the bottom. So your limit is going to be -1/6. Okay, so you look to factor and then substitute. So it's like one substitute, one little minor stop along the way. Where could it get difficult? It could get difficult in the type of factoring because you forget. In letter B, up top, well, you notice if I substitute in a 2 here, it's going to go undefined. So I know I have to look to factor. I have 4 terms. It's a cubic. You should remember how to factor that. If you don't, it's factoring by grouping. So if you remember from either my class or from Miss Daly's class last year, or I think Mr. Crane, factoring by grouping, Algebra 2, actually did in Algebra 1, not to make you feel bad. GCF the first side, so or the left side, so I can take out an x squared, leaves me with x minus 2. I GCF the right side. Now I'm looking to duplicate x minus 2, so I don't really have to do anything, but I do have to acknowledge that I'm taking out something. So what am I taking out? A +1. So when I go to factor this, I have whatever I have the double of, I take out. And then whatever's left, remember, I put back into a binomial. So x squared plus 1. And that's still over the original denominator of x minus 2. I notice I can then cancel out my x minus 2's. And now I have the limit as x approaches 2 of x squared plus 1. So substituting in now directly, my limit is going to be 2 squared plus 1, which is 5. So again, the trick here is not necessarily something new that we learned. It's remembering how to factor, which now brings me to C. Let's talk about this type of factoring, x cubed plus 1. Hopefully it pops out at you. X cubed is a perfect cube. 1 is a perfect cube. So it is factoring the sum of the cubes, which you should remember is SOAP, right? And then setting up your parentheses. I'm pretty sure we went over this year. But if you forget, I'm going to give you a little trick, right? We have soap. So when we factor the sum or difference of perfect cubes, what happens is you get a binomial and you get a trinomial. So the soap part of it talks about the signs. So there's a positive sign here. So the S in soap stands for same. And then the O stands for opposite. So opposite is your negative. And then the last two go together, always positive. So same sign, opposite, always positive. Now the inner parts, let me change my ink here. You're going to get the cube root. So you cube root x cubed, you get x. You cube root 1, you get 1. And then it goes square multiply square. So you're going to square this x. You're going to multiply them together. 1 times x gives you x. And then you're going to square the last guy. And that's how you factor sum or difference of the cubes. And then on the bottom, we still have that x plus 1. So that's going to cancel and leave me, I'm just going to drop down a line of x squared minus x plus 1. Do a little direct substitution. So negative 1 squared minus a negative 1 plus 1. That's 1 plus 1 plus 1 gives you 3. So again, the difficult part is really not in the concept of factoring and substituting. It's the concept of factoring that you forget about. So A, B, and C, right? We look to factor. We cancel any common factors and then substitute into the final answer. This last one, this one is a little bit messed up because nothing's going to help us here. So we're looking as x approaches 0, x minus 2 over x squared. I go to directly substitute in the 0. 0 squared is 0, so that doesn't help. And I have no way to factor this. So when you can't do anything and it's undefined, odds are it's going to be D, N, E. Okay, so keep that in the back of your minds. So now, me, skeptical, I always like to hit another method just in case this direct substitution doesn't work. If it doesn't work algebraically, well, then you always have a calculator. So what I want you guys to do is I want you to grab your calculator and I want you to go to your y equals, or you can watch with me. Unfortunately, I have an old calculator, so I don't have that alpha y equals. So I'm doing it the old way. X minus 2 in parentheses divided by x squared. If you look at the table, it's totally going to confirm that we are undefined at 0 because it has error. And I look, it looks like I'm negative to the left of it and I'm negative to the right of it. I'm going to zoom 6. I'm going to take a look at the picture. All right, if I zoom in a little bit, I mean, I know what's going on, but let me just zoom in so it's a little bit clearer. Oh, maybe not so much. I'm going to go back. I'm going to readjust. I'm going to go from -5 to 5. Clearly, you don't have to go through all this trouble for the window, but I'm trying to show you guys. All right, so if you guys look, as x is approaching 0 from the left side, it looks like it's going to -infinity, and that's true. If you look at 0 from the right side coming in, it's also going to -infinity. Now, remember, the limit is as x approaches a number, where's y going? But if they're both going to -infinity, it has to be a value. Infinity is not a value. Although you could say from the left side it's going to -infinity, from the right side it's going to a -infinity. But at the actual value of 0, there is no limit there. There's an asymptote. So the limit here is confirmed. It does not exist. So the limit does not exist. And for those of you that watched Mean Girls, I always think about that last part. And I was actually in the movie theater with a bunch of math teachers for that last part of the video where the limit does not exist. So it was very fun for a math teacher. The limit does not exist because it's not heading to a finite number at x equals 0. Okay? So there you have it. So today's lesson, nice and easy. Look to directly substitute like the first page. On the second page, we got to work a little bit, look to factor and then substitute. But then sometimes your best efforts aren't going to work, like in letter D. So then hit up your calculator, take a look at the table, take a look at the picture, see if you could figure out the limit. This is probably one of the most important lessons for your foundation of calculus. So I thank you for watching the whole video, and I hope you have a great day. Hope you made it through your APs okay. All right, talk to you soon.